Okay, in the second part of the video, I'm going to discuss about asymmetric algorithm. Remember, we use two mathematical keys. We use two keys instead of one key. In my previous video, symmetric key, we only use one key. So the data is encrypted with one key and can only be decrypted with another key. This is also called public key cryptography. Okay. Asymmetric algorithm provide message authenticity and non-repudiation. Okay. For confidentiality purpose, user A encrypt message using user B public key and then send it to user B. Then user B will decrypt the message with his private key. So this is much better than the above. All right. Some example or popular asymmetric algorithm, right? I'm gonna put here popular asymmetric algorithm. The first one is called RSA. This is developed in 1977 by Rives, Shamir, and Edelman. That's why they call it RSA. First algorithm used for both encryption and digital signing. Okay, many browsers using TLS, Transport Layer Security Protocol, right? Use on a one-way function to generate key, and mathematical formula is easy to compute in one direction. So RSA is quite popular, all right, because many browsers use this one, all right. Let me see what else here. The second one is called Diffie-Hellman. Diffie-Hellman is also popular, all right? It's Diffie-Hellman asymmetric algorithm developed by Diffie and Hellman. However, this one does not provide encryption. Used to establish a secret key share between two parties. Each party generates a shared key based on a mathematical key agreement relationship. If the key is intercepted during transmission, the network is vulnerable to attack. With a method of sharing secret key, users secure electronic communication without fear of interception. So RSA, Diffie-Hellman, and then we have the third one is called elliptic curve cryptography. Okay, let me put this is number 3. ECC, okay. ECC used for encryption and key distribution. This is more efficient algorithm because require fewer resources, memory, disk space, bandwidth, and digital signatures. The next one, El-Gamal. El-Gamal is also popular, right? Used to generate key, encrypt data, use digital signature. El-Gamal, written by Taher El-Jamal in 1984, right? Use discrete logarithm problem. Solving a discrete logarithm problem can take many years and require CPU-intensive operations. So this is a good algorithm. And then we have a digital signature, right? Digital signature enable public key to decrypt a message encrypted with private key. Public key can decrypt a message encrypted with a private key. So only if the message was encrypted by corresponding private key holder, right? So this digital signature enable a public key to decrypt message encrypted with private key. So the public key is used to decrypt. The public key can decrypt the message encrypted with a private key. All right. The next one, here they give you example, right? For example, Gloria created a message to send to Paul, right? The hash value is calculated from the message. Gloria private key encrypt the hash, and then the Paul decrypt the hash value with Gloria public keys, and then Paul calculate the hash value on the Gloria message and verify that the hash is the same. So Paul can read the message. So Gloria private key encrypt the hash. The hash value is calculated from the message, and Gloria, the sender, encrypt the hash, and then the Paul decrypt the hash value using public key, Gloria public key. Then the Paul check, make sure that the hash value is the same, right? The hash value is the same. So if the hash value is different, then that message has been intercepted. By the way, when student log into Blackboard, I posted MindTap Labs exercise of hash value. Please do that, all right? So this is how digital signature works. Digital signature standard established in 1991, okay? Ensure that digital signature can be verified, right? Federal government requirement, RSA and DSA must be used for all digital signature, right? So we use this RSA, reverse, Shah, and what's his name? Amir, right? Is that Amir? I have to check that. Let me see. RSA here. Reverse, Shamir, and Edelman. It's Edelman. Alright. Hashing algorithm must be used to ensure message integrity. We use SHA, right? You have SHA 1, SHA 2, and SHA 3. As a secure hash algorithm 3 is the latest one. Okay. Let me see. Alright, I think I'm gonna stop right here. Alright. I'm going to stop right there. Alright. So hopefully that this video lesson give you a good overviews about symmetric and asymmetric algorithm, right? As you can see, we have our 58 slides, so I just point out the important stuff that students need to know. This will be the last lecture for the semester, since I already covered chapter 13 or module 13 about network protection or honeypot in the previous week. So hopefully students are staying up to date with all the tasks. If you have any question, please email me through Blackboard and I will respond your email within 24 to 48 hours. Today is April the 30th, which is Thursday, right? So we have about 2 more weeks to go. Make sure that student complete exam number 3. Okay, that has to be done before final, and then you can do the final exam. All right, or if you prefer to do the final exam, then you can complete exam 3. Let me show you the last day of classes. All right, the last day of instruction is May 8th. Okay, this is the last day of instruction. So students should complete all the exam and all the tasks on the 12th, okay, because it takes a while for me to grade your essay, especially with the labs. Okay, so I have a few days to grade the system. So the last day of taking any test is at May the 12th on Tuesday. Okay, the latest is on Wednesday. Okay, the deadline is May 12th, the latest is 13th. All right, since I need time to grade the works. All right, thank you very much, and hopefully that you learn some foundation knowledge about ethical hacking. Again, if you are interested in this field, you still need to go deeper, study more, right, in depth. All right, we learn about many different tools in the ethical hacking. In penetration testing, if you are interested in this security field, focus more on some of the tools. What your specialization? Maybe you want to become a penetration tester. So make sure you learn the networking very well, the operating system, Windows, Linux, and Mac. Okay, 3 operating system you need to learn well, and then the networking part. All right, thank you very much and have a wonderful day.